हॅलो एव्हरीवन, मी सचिन गवारे. आज आपण डेफिनाइट इंटिग्रलचं थर्ड आणि लास्ट लेक्चर घेतोय. त्यामध्ये आपण उरलेले 3 प्रॉपर्टीज कंप्लीट करतोय. सो नेक्स्ट इज प्रॉपर्टी नंबर 6. Next is property number 6. Now what is the property number 6? Integration from 0 to a, integration from 0 to a, f of x dx equals to integration from 0 to a f of a minus x dx. Now, to prove this property, let's consider the RHS. Now, RHS is integration from 0 to a f of a minus x dx. Now, here make the substitution, that is put a minus x equals to t, which implies that if we differentiate both sides, we get dx equals to minus dt. Now also changing as hello also as x tends to 0, x tends to 0, t tends to a, t tends to a, and as x tends to a, t tends to 0, t tends to 0. Now, if now after this substitution of these terms, RHS becomes RHS equals to integration from a to 0 f of t into minus dt, f of t into minus dt. Now take the negative sign outside the integral, so it becomes integration from a to 0 f of t into dt, f of t into dt. Madam, f of t into dt. So now by using the property, this can be written as integration from 0 to a f of t dt. आपल्याला प्रॉपर्टी माहिती आहे, जर आपण लिमिट्स इंटरचेंज केले डेफिनेट इंटिग्रलचे तर त्याचं काय होतं, साइन चेंज होतं. सो अगेन बाय युजिंग द प्रॉपर्टी दॅट वी कॅन replace the variable or we can change the variable. This can be written as integration from 0 to a f of x dx, and this is our LHS. This is the LHS, and hence the proof. Check out. To prove this property, we consider the RHS, and in RHS we substitute a minus x equals to t. After changing the limits of the integrals, we get the solution of this property, that is property number 6. Property number 6. Now the next property. Now property number 7. Now the next property number 7. Now the statement of property number 7 is integration from 0 to 2a. Integration from 0 to 2a f of x, integration from 0 to 2a f of x dx equals to integration from 0 to a f of x dx plus integration from 0 to a f of 2a minus x dx. 2a minus x dx. Now, to prove this property, we consider second part of the RHS first. Now, so let consider I1 equals, let's say I1 equals to integration from 0 to a f of 2a minus x dx. F of 2a minus x dx. Now here put 2a minus x, 2a minus x equals to t. Now after the differentiating and adjusting the negative sign, we get dx equals to minus dt. Dx equals to minus dt. Also as x tends to 0, x tends to 0, t tends to 2a, and as x tends to a, t tends to a, t tends to a. Now, making this substitution in I1, this I1 becomes, I1 equals to integration from 0 to a, sorry, it becomes integration from 2a to a, integration from 2a to a, f of t into minus dt. Now take the negative sign outside the integral, so it becomes minus times integral 2a to a f of t dt, f of t dt. Now, by using the property of definite integral, if we interchange the limits, upper limit and lower limit, the sign will be changed. So by using that property, this will be integration from a to 2a, a to 2a f of t dt. Now again, we can change the variable. We can change the variable in definite integral. So it becomes integration from a to 2a f of x dx. F of x dx. So finally we get I1 equals to, finally we get I1. I1, what is the value of I1? The value of I1 is integration from 0 to a f of 2a minus x dx. So this value of this I1 becomes, that is integration from 0 to a f of 2a minus x dx equals to integration from a to 2a f of x dx. Give it is an equation number 1. Now, after giving it equation number 1, consider the RHS. Consider the RHS of the property. Now, RHS equals to, RHS is integration from 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now putting the value of this second integral from equation 1, we get, or the RHS becomes integration from 0 to a f of x dx plus a to 2a f of x dx. Since 0 is less than a is less than 2a, we can use the property of definite integral. So by using that property, this becomes integration from 0 to 2a, integration from 0 to 2a f of x dx, and this is our LHS. This is our LHS. Now, see again, to prove this property number 7, we take the second part. We take the second part of an definite integral, and in which we take the second part on RHS, and in which we make the substitution 2a minus x equals to t. After that substitution and applying the property, we get the value of integral 0 to a f of 2a minus x dx equals to integration from a to 2a f of x dx. Now putting this value in RHS, consider the RHS and use that value, we get the LHS of an given property, and hence the proof of property number 7. Now the last property, proof of the last property, that is property number 8. Property number 8. Now to take the proof of property number 8, first we need to know the two types of functions. First one is the even function, definition of even function. Now, if the any function f of x, any function f of x is said to be even, if f of minus x equals to f of x, and second one, the function is said to be odd function. A function is said to be odd function if f of minus x equals to minus times f of x. Minus times f of x. Now we use these two definitions of the even and odd function in this property, last property, that is property number 8. Now what is the property number 8? The property number 8 is state that integration from minus a to a f of x dx equals to, it gives two values depending on the nature of f of x, that is it is equals to 0 when f of x is odd function. F of x is odd function. Odd function. And this integral becomes 2 times 0 to a f of x dx when f of x is an even function. F of x is even function. Now we have to prove for these two cases. Now to prove the property, this property, now consider the LHS. Now in LHS, now the LHS is integration from minus a to a f of x dx. F of x dx. Now clearly minus a is less than 0 is less than a. So by using the property of definite integral, we can split the given integral at 0. We can split the given integral at 0. So this LHS becomes integration from minus a to 0 f of x dx plus integration from 0 to a f of x dx by using the known property of definite integral. So this is the value of LHS. This is the value of LHS. Now give this is an equation number 1. Now this is an equation number 1. Now in equation number 1, consider this first part. Consider this first part. Let it is I1, which is equals to integration from minus a to 0 f of x dx. Now we simplify it. Now here make the substitution, that is put x equals to minus t. X equals to minus t, which gives dx equals to minus dt, and also as x tends to minus a, t tends to a. T tends to a, and x tends to 0 means that t also tends to 0. T also tends to 0. Now, making this substitution in I1, this I1 becomes integration from a to 0 f of minus t into minus dt. Again, taking the negative sign outside the integral, so it becomes minus times integration from a to 0 f of minus t dt. Now, by using the property of the definite integral, we interchange the limits, so its sign will be changed. So it becomes integration from 0 to a f of minus t dt. Now again, by using the property, that is, we can change the variable. So this can be written as integration from 0 to a f of minus x dx. F of minus x dx. Now putting this value of I1 in LHS, putting this value in LHS, that is, put in equation 1, the equation 1 becomes, now putting in equation 1, put this value in equation 1, we get LHS equals to integration from 0 to a f of minus x dx plus integration from 0 to a f of x dx. Now here both the limits or both the limits of the definite integral are same, so combine them. So this can be written as integration from 0 to a f of x f of minus x plus f of x dx. Now this is the LHS. Now here we consider the two cases. That is, one is the when f of x is the even function and f of x is the odd function. Now case first, let f of x is odd function. F of x is odd function. Now what is the definition of odd function? Or we say that when f of x is odd, it means that f of minus x is equals to minus times f of x. Now putting this value in LHS, and therefore the LHS becomes, integration from 0 to a minus f of x, because the value of f of minus x is minus f of x for the odd function, plus f of x dx, plus f of x dx, and this becomes 0 because this plus f of x and minus f of x gets cancelled. Now this is the first case. Now for the second case, case 2, let f of x is even function. Now, since f of x is even function, so we can write as f of minus x equals to f of x by definition of the even functions. Now, putting this value in above LHS, this LHS becomes integration from 0 to a f of x plus f of x, because f of minus x becomes f of x since it is an even function dx. Now we know that f of x plus f of x gives 2 times f of x. So it gives 2 times integration from 0 to a f of x dx. f of x dx. And we get the proof of the property number 8. We get the proof of property number 8. Okay, and so here all the properties of definite integral are completed. So we stop here. Thank you.